Tuesday, and this is the stuff that's in store for today if I can manage to adhere to the plan, which is not guaranteed. And meanwhile, what I want to do is several things at once. So we're continuing to just look at the practical aspects of running and surviving PV. Just out of whatever, well, more than curiosity, informed curiosity, how many of you are trying to run PV and not succeeding? 1, 2, not so bad. 3, okay. One of you emailed me on Yahoo and didn't have 4 and didn't have sound coming out.
I figured that out.
Oh, it had. Okay.
It was weird. It didn't show me any numbers though with the outputs, but when I didn't test tone, after a little bit of restart on my computer, it came up.
That's what, yeah.
It was kind of strange.
Something like that's been happening to me today. It hasn't happened before, which is that I've had to try twice to get it to run.
I use like the version 43 instead of 42 because that looks more familiar from the one we looked at class.
Yeah, right. So, and I'm not sure which I should propose. I think I'm running 42 right now, but it's roughly the same. I'll tell you one thing that doesn't work in 43 in case you were running 43, and this is something I still can't figure out how to fix. What are anyone for whom it's not working, can you tell me what symptoms you're getting?
It wouldn't allow me to put any objects.
Wouldn't allow you to put in objects?
On the quick menu, everything wasn't
grayed out.
allowing me to select it.
Oh, maybe. Maybe you're looking at the PD's window here and trying to do put.
Oh, maybe.
And for that, you need to be actually talking to a real document. Oh, yeah, I didn't actually say this explicitly, but this is PD's printout window, which exists mostly, I believe that PD is actually running. And you can have this, but it won't be doing anything until you have some number of patches open. And you can have 1 or more patches open, and they're all running all at the same time. And furthermore, they can talk to each other, so you should be aware of that possibility. Other PD, yeah?
I can get a single sine wave to play and try putting another oscillator in that to get the crazy stuff.
Didn't get it, okay.
Like you heard a clip and then it was just gone. But it might be my computer being bad.
I think I might know what happened to you, and that's something I'm going to try to address today. It could be that what you're doing was numerically outside of the range of the possible values it can convert. And there are ways that you can do that would cause it to make silence. And that's a gotcha that I want to try to help you avoid today, if I can succeed. Yeah.
I'm just having problems downloading PD on my computer.
Okay, PC?
Yeah.
Yeah, okay. I got a PC today, and maybe, but I'm not sure if I'll have the same problems as you do, but if you see me do something that you're not doing, that might help. Otherwise, maybe after class we can look at it. Yeah.
Do you know when a 64-bit version of PD extended for Ubuntu is going to be?
For Ubuntu?
Yeah. 32-bit version of that.
Yeah, I don't know when that's. I think that last I heard, someone had a machine that they were going to try to compile it on, but no one knew when it was going to really happen. So you might have to do it yourself. Other questions or things? Yeah. Okay. So next matter. Oh yeah, I have another thing to sort of just check off, which is the class didn't exist as far as WebCT was concerned on Tuesday, but that should be fixed now. Yeah.
Yeah.
Good. And is it decently clear how you would upload assignments? I have one slight comment to make, which is that it's possible to get confused downloading patches on the web. I actually don't know if I'm on the network, so I don't know if I can show you this, but I can tell you this. If you see a patch on the web, such as, for instance, the patch that I saved from Tuesday, which is on the website for the course, you could click it and it will just download you a nice patch, or you could click it and you will see this bizarre text in your browser. And if you click it and see text in your browser, that's because PD patches are in fact text files. And if your browser sees that it's text, it might just decide to show you the text instead of save it to you as a file. This is not a problem. Just save it as a file anyway, and make sure it ends in .pd, and then tell your computer that .pd things are pure data documents, and then you're happy again. But I regularly get emails. Oh, I tried to download this patch and I just saw gibberish on my screen. Okay, patches are gibberish, and you saw your patch. If you're curious, by the way, you can look and see what patches are. They're just text files, and they just have gibberish in them that describes how you make a patch. And furthermore, those of you who get too excitable too late at night, if you learn what those messages are, you can generate those messages from PD, and you can make patches that build themselves. I'm not going to show you how to do that, though. I'm going to figure that out. Or actually, everyone on the web is doing it, so you can find it easily. Okay. Just so I can shut this window down, I'm going to put this up on as a sort of review for today. But what I want to show you now are two other objects. Wait, I forgot something. I actually gave you 6 objects last time because there was also the push button. Whoa! Okay. Right. Okay, so this is saved. This is my resume from last time, and what we're doing this time is another control, which is number boxes. If you do that, that suddenly means now you can make wonderful analog synth type sounds. And arrays, which are graphs which you can do this with. Okay, and these things are functional objects which I will grab and use as needed as we get through today's stuff. Today's stuff is mostly going to be figuring out what went wrong with last time's stuff, although I'll show you how to make FM too, which takes 1 minute. Okay, so now what I'm going to do is watch this. Say Control Alt backspace. That's the equivalent of making a new document, but now I'm going to say Save As. And I'm going to give myself a new file name so that I can make a nice checkpoint. Whatever. And this will be built, and then I will try. And by the way, you can remind me to do this. I'll try to save these things as before I erase major portions of them, so that you can sort of see in a progression what happened as we went through the day. All right. Now, review. Let me just make the patches of last time very quickly and show you how you can see what they're doing in other new ways, and then go on from there. So oscillator 440 volts, 440 hertz, please, and then I'll say, oh, if you have an object selected, and if you hit the key accelerator for make a new object, it doesn't just make a new object, but it makes a new object and connects it to the previous one. That it doesn't matter to you now, but late at night when you're making hundreds and hundreds of objects, you'll get to like this feature. I think most people like it. I'm going to multiply by 0.1, which is a tenth. And then I'm going to send us out a digital analog converter. Ta-da! Okay, now I'm going to turn USB off. Good. Okay, so this is the sort of hello world patch, right? Now, what I'm going to do is show you not just how to print stuff, but how to graph it. So to print stuff, this is from last time, we would say, give me a print object, print tilde, by the way, because it's print with a signal input. And now I'm going to talk to this 0.1 thing, and then I'm going to make a push button. Oh, wait. And now, and this is the thing that I forgot to tell you for the first 70 minutes of the other class. You're not going to get very far just trying to click this button like this, because I am in edit mode. I want to get into run mode, and then I can click it and have stuff happen. Except nothing happens because the DSP is off. Okay, so these are the numbers which correspond to 164 sample buffers worth of sound. this is see it, as in an oscilloscope or as in a sound editor. And that, I'm going to introduce that because I'm going to be using it to go back and make sure everyone can understand about amplitudes and frequencies and modulation again, and even what the word modulation means. So to do that, so new material starts now. There's a wonderful object called an array, which you can get down here. This is unfortunate. There's a thing called a graph, which is a rectangle that you can throw arrays inside. This is an array, which is the thing that you throw inside the rectangle, which is more likely to be the thing that you want, because this will just give you an empty rectangle and no idea how to stick an array inside it. Well, there are ways, but I'm not going to tell you yet. So get an array like this, and it immediately says, I want to know all this nonsense about the array. The important nonsense is what's its name going to be? I'm not going to tell you yet all about PD's naming. That's going to, how PD treats names as a subject in and of itself, but I'm just going to use a name for now. In fact, array 1 sounds good to me right now. And a size, this is the number of points that the array is going to have. So that number would be, for instance, at our sample rate, if I want a whole second of sound, I would have to ask for 44,100 points here. As a general thing, PD doesn't know much about sound. It doesn't know that a second of sound requires, say, 44K1 points. And anyway, that number might change because the sample rate of the computer might get changed while PD is running. So it doesn't make sense to ask for an array that holds a second of sound. So you have to go on and tell it numerically how much sound you want in the array. In the same spirit as you had to tell the oscillator how many cycles per second it had to vibrate in order to make you a nice A440. Well, what I call A440, which is concert A4, I think. So here, I don't want 44,100 points. I want 1,000 points just for now. And this is aesthetics, but I prefer points to polygons. Polygons are, well, polygons means it draws little segments between the points, and points means it just draws the points. So I'm going to choose points just because it's me and that's my preference. And I'm going to say, OK. And it says OK, and it draws me a thing. Oops, so I'm not in edit mode, so let's get in edit mode and pull it around. It says, hi, my name is array1, and my values are all 0. By default, these values range from -1 to 1, which is the same range as audio is, which is a good thing. And now, well, for instance, that's a good thing because I can now use that to graph what's coming out of this network and show you what it looks like as an audio signal. And let me do it wrong again, in the same way as I did the other thing wrong. So I'm going to need, I see, I got the window. Come here. I'm going to need another push button, and I'm going to need an object whose name is tab right. That's an ugly name, but it fits in a series with a bunch of other names, so it has to be named the way it is. And then I'm going to say what table, that's to say array, you're going to write to. Nomenclature. In computer music, arrays were called tables. This has been true since 1958. And there's confusion in PD as to whether something should be called a table to be true to its computer music roots or to be called array, which is what the thing really is, which is just a bunch of things all of the same type. So the name sort of flops back and forth between things that say table or tab right and things that say array. And I apologize. You never know what's going to happen if you develop something for 20 years. Okay. Now I'm going to listen to this thing by connecting it here. Notice again, as I mentioned last time, these are skinny wires that hold or carry messages. And these are fat wires which carry signals, and those are different animals. Signals are happening all the time, and messages are happening only sporadically. And now I'm going to click this, forgetting that I have to lock the patch. So I'll lock the patch, and then I'll click it, and nothing happens. Why? DSP is off. Go up here, turn on DSP. That's why I left this thing on the screen. And then, ta-da, we are looking at, oh yeah, so I'm going to start using the accelerator now. Good. now DSP is off, but we just wrote into the array. So in the same spirit as for the print tilde object, this thing has an audio input, but what it does is something that it does sporadically. That's to say when you want it to do it. And so you have to send it a message, a trigger, if you like, to say do your thing. And doing your thing consists of, or amounts to, holding on to, well, commencing to record the audio signal that is coming in and continuing to record until you reach the end of the array, at which point you stop. It doesn't loop around. You can make it loop, but by default it just does it once.
What was the shortcut to DSP again?
So what?
What was the shortcut?
Oh, the shortcut for DSP. I don't even know if this is documented. Control slash turns DSP on and control dot turns it off. The control dot is fairly standard Macintosh language, and the slash is just next to the dot. Yeah?
How did you get the array to look like that?
To look like that?
Yeah, did it by writing the tab breaks? When I turned my DSP on, it didn't do that.
Yes, okay, so I did two things. One is I clicked the tab, I clicked this button. I did that while I was out of edit mode.
Oh, okay.
In fact, if I do it again, oh, nothing happens because DSP is still off. Okay, turn DSP on. Hello?
Okay.
Can't turn DSP on.
I was just in edit mode.
Okay. Now, with DSP on, each time I click it, it'll make a new recording. And now, you know what? I should really. That's all right. I'm going to leave it the way it is. Is this clear? Yeah.
How do you edit array 1?
How do you edit array 1?
Like, you go back. Like, if I wanted to change it to dead tab.
Oh, I see. If you want to change the size, right? Okay. So I was going to forget to say this, and by the way, this is very confusing. If you left click, if you have a more than one button mouse left click, and if you have a Macintosh that only gives you one button, I think you command click or option click, I forget. It gives you properties or open or help, and do properties. Open means, hi, I'm a subpatch, and I only contain this. It's okay, but that's good for other things. Properties is going to do this. It's going to give you, watch out, 2 windows, because there really are 2 things here. There's the array, which is the squiggly line, and then there's the graph, which is the rectangle it's in. Okay, so when I asked it to make an array, it made me an array and a graph, and put the array in the graph. Okay. By the way, there's no intellectual content in any of this. This is just PD lore, right? Okay. So this is the array. This has to do with the points in there. And for instance, there are 1,000 of them, and I could ask it, oh, let's have 2,000 of them. And then I'll say apply here. And it's going to be a little embarrassing because it only had 1,000 good points, and then the other 1,000 are now 0. It did have the decency to change the bounds of the graph so that the array still fits in it. But that's about all it did for us. Okay, and now I'll do back to 1,000, like that. OK means apply and then disappear. And then the other thing is, where'd that graph thing go? Just left. So let's start over. Oh, I'm drawing a polygon again for some reason. Okay, and now let's get the properties back so that we see not just the array but the properties. Now here we can say the x. All right, x and y really mean the horizontal and vertical axis, right? X is going to range from 0 to 1,000. That means this point here is 0.0, and this point here is actually 0.999 because there are 1,000 points. If I change that, you don't need to remember this. You get the following embarrassing result. The graph wants 2,000 points, but the array only has 1,000, so it looks stupid. And I could also say, oh, the range is only 700, say. And then we get, it doesn't do it. Oh, yes, because I'm running 43, and there's a bug. So we'll say 1,000. You can't, if the array doesn't fit in the graph in 43, it doesn't draw it. That's bad. And it's going to take me hours to fix it because there's something subtle wrong there. So so make sure, so if your thing isn't drawing, it's because it doesn't fit in the graph. And my apologies. Go back to 42 if you really need to see it. somehow didn't realize I was running 43. That's good. Okay, so we're going to cancel this. Oh, except I'm going to do this. The Y range goes from 1 to -1. Isn't that ugly? That's because computers think numbers go up that way, whereas mathematicians think numbers go up that way, or graphs think numbers go up that way. So you have to say, yeah, I mean, I could say it goes from -1 to 1, but everything would be upside down, which would be confusing. But for right now, I'm going to say we'll go from 2 to -2, so that you can see that the thing drops in size, because now this is 2 and that's -2. There are ways of getting the thing to show you what its bounds are, but let's leave it that way. Okay. And I'm going to just leave it like this. Okay. So now, just to belabor a point, I'm going to disconnect this so I can have DSP running and not listen to it. And now I'm going to just now I just asked it to graph the output of the oscillator and not the output of the multiplier. So now you can see what a full blast oscillator looks like. So now recall, I have the graph, that's the rectangle, going from 2 to -2. The signal, the oscillator signal, ranges in value from -1 to 1, which is full blast as far as the computer is concerned. You can make signals that are more than full blast. These numbers are all floating points, so you can have numbers that go up to 10 to the 37th power, or something like that. Your speakers can't play those. Right? And it's a good thing because you would vaporize the planet if you could. But as long as what goes out is between -1 and +1, then your computer will, I hope, faithfully turn that into voltages that your earphones or your stereo can do. All right. Just for pedagogy's sake, okay, this is the moment I think perhaps to save this patch and continue. I'm going to save it, and then I'm going to save it as range, signal range. All right. I'm going to now show you what happens when you... Oh, I'm going to turn the volume down on the room before I do this. And I'm just going to play the oscillator full blast into the speaker, or into the mixer. But the mixer's volume is going to be down, so we won't lose our eardrums. And then I'll show you what happens when you add another one, which will cause things to malfunction in a novel way, which actually you might already have heard a couple of times. So let's see, I don't want this anymore. Don't want this anymore. And I'm going to turn the volume down. Okay, and then I'm going to connect this to this. Actually, what I should do is turn it off. You know, it's too much for the mixer. You can hear already that it's not a clean sinusoid, but we'll pretend it's a clean sinusoid because I'm about to make it even worse. I'm going to say, okay, that's good, and I also want one going at 550, which is a perfect third above 440. Oh, first off, I'll do it. Okay, hear that? Now, ready, set. What happened? Clipped. Yeah, okay, good. So those of you with digital audio experience know what's going on here. But I'll graph it for you to show you what's really happening at the level of the signal. And to do that, I have to introduce the final object for the day, which is clip tilde. And this is one of those minority objects which sometimes you just need it, but those times are maybe only once a week or so. All right, so here it is, clip. This is, clipping is, it's a term that, I don't know how old it is, but it certainly dates back to the old analog electronic days. It simply means what happens when a signal goes out of the range of the audio device that is receiving it. So the standard thing about clipping is you would hook an electric guitar up to an amplifier and overdrive the tubes And if you overdrive a tube, well, there's a maximum and minimum current that the tube can put through. And beyond that, it just says, well, I'm clipped. I can't go any further, so I'm just going to stop right where I am. Right? So it's like in this building, if you ask for floor -1 or floor 4 on the elevator, you won't get them. You'll only get down. You'll get floors 1 through 3 because that's where the elevator goes. It's the same deal. So, for instance, I'm going to clip between -1 and 1, which is an exact imitation of what actually happens when the audio goes out of your computer, because the range of possibilities is -1 to 1, and if it's out of the range, it is simply clipped to the range. And if I do that, and if I, for instance, add these two oscillators together. Oh, before I do that, sorry. Before I do that, I'm going to do this. First off, why can't I? There we go. All right. So here's the first thing. Oh, right. We're only listening to one of them, so let me play you both of them and show you both of them. So what's really happening is the periods of the two oscillators that we have are short. Each of them is fitting 20 or 25 cycles in the thing, but what you can see is that the thing itself is repeating at this much lower rate, which is in fact what is it now? It's the greatest common factor of those two frequencies, if you like, or the least common multiple of those two periods. Okay? Or now, finally, to show you what the computer to show you what the computer really is playing, let's look at it this way. Rather than add it right into the tab right, we'll add it into the clipper and do tab right and then do that. Aha! Now, the signal that you saw before, even though the signal that you saw before was clearly periodic with this period, you didn't hear that period because, in fact, in its internal structure, it really only had two components, each of which had a much shorter period, and your ear resolved those. It didn't make a difference to them. It just heard the individual harmonics. It couldn't fuse them, right? Or at least my ear couldn't. But if you clip it, you make that be no longer true. There's simply no possible way you can hear the signals having any period other than the period that it's got. Yeah?
The little toggle button.
These? Oh, this is not a toggle. This is the button which is called bang. Oh, and if you get a toggle, you'll get another rectangular thing, but it's a toggle switch which goes on and off when you press it. That's for later. All right, so this is clipping, and this is what your audio hardware does to you. Now, let me show you how you can make your life even worse. I think this happened to one of you, but I'm not sure. I'm just operating on a guess now. So I'm going to say, hi, be an oscillator like this. And now, I'm going to listen to my nice A440. And then I'm going to add another oscillator. Ready? Oh, that's not what I wanted. Oh yeah, I miscalculated. I'm going to add another one. Oops. What happened here is this. Let's see. Okay, so let me put it in the let me do that same thing. You know what? Yeah. Okay. So now we're clipping. Actually, you know what? I can save some steps by just listening to the clip down. Now we do this, and this is a problem because it's the sum of a sinusoid and another sinusoid that has 0 frequency and 0 phase, which means its output is 1 volt. Right? And the result is that half of the cycle is below 1 still. The half that was from 0 to -1 is now going from 1 to 0. And the half that was going from 1 to 0 is now going from 2 to 1, and it's getting clipped. Okay? In fact, when you learn how to control this, you can have a lot of fun because you can do this controllably. You can change the timbre of sounds by selectively clipping more or less of guitarist is the bias knob on your Ampeg amplifier thing. Fender doesn't give you the bias knob, but the other manufacturers do. Okay, and now I'm going to add another one. And what do you know? The patient died. And the reason
Worse.
the reason the patient dies is now the entire sinusoid here lives above +1, and so it got clipped to +1, and so the result is the signal that you can't hear. You can only smell it because it will melt your speaker. Speakers theoretically will go down to 0 ohms at DC, and your stereo probably won't do this to your speaker, but if it could, then you would have to call the fire department or something. All right. So this is how to make your life hard by making signals that are out of range. And and so the first thing you hear is funny distortion, but you don't know whether the funny distortion is your patch or whether it's just because your earphones are bad or something like that. And then when the signal goes away altogether, well, you still don't know which it is, but it's very possible that it might be this. Might be a good idea to equip yourself with one of these things at the same stage as you're making your output. So, for instance, one thing that might be a really good idea would be whatever we do, we'll just put a nice adder at the bottom. Doesn't matter whether we're adding more than one thing or not. This adder really is just here so that whatever to remind me that whatever's going out the DAC is going to go out it's going to be graphical as well. And now if I, for instance, do this, then I can both see an ad here. Now, when you're turning in homework, oh, go ahead.
What was the adder for? Because I didn't see it.
Oh, what's the adder for? The adder is there because when I add or take out stuff, I'm going to hook it into the adder instead of hooking it into the DAC, into the tab right. And that way I'm not going to forget to run something into the DAC that I didn't run into the tab right. So really it's adding 0. Oh, I'm going to explain more about adders in a second, but all I'm doing really is adding 0 to the signal, so I'm just wasting operations really. But the reason I did that was so that I could start doing stuff like this. In fact, it doesn't even matter which. You wouldn't even need an adder in PD at all because signals automatically add anyway, right? Okay. Well, okay, that's not quite true. For reasons I will tell you next. Other questions about that? Yeah.
Wait, so is the adder unnecessary? Like, can you just...
The adder is unnecessary. It's only there so that when I make a connection to it makes the connection both to DAC tilde and to tab right tilde.
Okay.
And I could do that in a stiffier way, but I'd have to use another object, so I'm just going to use an adder. Oh, so now what I'm going to do is put this object in a nice state so that you might be able to remember what I was doing. This is going to get saved. And then I'm going to make a new thing and start doing other stuff. Okay, so I'm going to insult your intelligences for a few more moments. And talk once again about amplitudes and frequencies and graph them because I sense there is still confusion about this, and I don't know how to simulate this confusion in my own brain, so I'm just going to try to confuse you and hope that you stop me when things get confusing. So here we go. We're going to now take away all the cruft. Oh, I didn't say this, but of course I didn't give this oscillator an argument, so that means it's going at 0 hertz until I tell it otherwise. But I don't care about that. Oh, I need to mention something else that's going to happen to you. If you open 2 or 3 of these patches at once, and if you have an array named array 1 in all of them, or in more than one of them, you're going to get complaints because PD will have 2 things named array 1, and the name is supposed to let it figure out which one that you're talking about. So if there are 2 of them, it's confusing. PD will print you out a warning message and it will choose one of them for you, which is probably not going to be the one you thought it was going to be. And so what I'm going to do for that is I'm going to now change. I forgot to do one, so I'm going to try to remember later. But I'm going to change the name of this one to array 3. And we're going to very even see if it's working. Yeah, okay, we're good stuff. All right, so now we don't need to clip anymore. What I'm going to do is I'm going to introduce the last thing that I have to introduce today, which is the number box. Oh no, second to last, sorry. I'm going to start with, okay, so there are 2 distinctions that are going to be important for the next half hour or so. One is frequencies versus amplitudes and inputs versus outputs. In other words, how you change the amplitude or frequency of the sound and what it looks like when you change those 2 things in terms of the graph. That's one thing. And the other thing is that I have to give you some more details or more information about distinctions between messages and signals. And these 2 things, I don't see how to separate them very well, so I'm going to just sort of fold them together into one discussion. Okay, so the first thing I want to do is this, go back and show you the oscillator, but give it a variety of frequencies. Let's see. Here's my 440 hertz. And then if I start changing it, then I see this kind of changing. All right. Okay, so now we've got a nice theremin or something. You will find this very hard to play musically. And try more about that later, perhaps. Now, that is changing the frequency of the oscillator. This is the same thing in some way as telling the oscillator that its frequency should be some number like this. You could even do this. Maybe don't, but you could say, hi, sorry, go away. The oscillator is now 440 hertz, but meanwhile I'm going to change it. You know, this is perfectly legal, but this is confusing. This is confusing in one of the 2 ways that you can be confusing in PD that I know of, that I can think of right now, which is that I initialized the frequency to 440, but then I overrode it, or replaced it, if you like, with the value 205. This is not good style. I'm doing it to you to show you how you can confuse yourselves. The reason you can confuse yourself now is that you can think that this number is still 440 because it says so right here, but it's not because I changed it. It would be smarter if I am going to run something in that's going to change it, not to give it a value that in fact isn't going to be reality after I do something to the patch. Okay. Although it's perfectly legal to do it. So now, the other thing that I want to do now is say, oh, so that's why I'm saying oscillator without an argument now, because I have a number box hooked up to it and I'm trying to be hygienic about the way I'm making this patch. So the next thing is going to be, now I'm going to start changing the amplitude, which recall one does with a multiplier. What I showed you before was, oh, we can multiply the thing by some number like a tenth, and then we will get something that looks like this. What do I do wrong now? Oh boy, this is the oldest mistake in the book. Now what I've done is the oscillator I made a new oscillator, so its frequency is 0. And I have this nice number box going into it that thinks it's 205, but I haven't actually sent the oscillator the message 205 since I've made it again. So let me fix it and then break it again and then fix it again so that you'll see this, because this is a thing which can be confusing. Okay, so I'll say, all right, good, 220 please. You're at 220 hertz tone. By the way, it's quieter now because I'm doing this other thing, but it's good. And now I'm going to say, my oscillator, I want it to be something else. No, I actually just want it to be an oscillator, thanks. I hit Control Z there to do undo, right? And nothing, because it didn't really undo the change, it just made me a new oscillator tilde, a clean one. And it's clean in the sense that it hasn't received any messages that might change things like its frequency or its phase. So it's sitting there at frequency 0, so it's actually putting out the value 1, so I should be looking at 0.1 here, although I'm sure that's true. And that will be true until I do something like touch this, and once I touch it, then the value 220 is out. Yeah?
Can you engage it too by taking out the input and reconnecting it?
No.
No.
Yeah. So this would not work. Actually, another way to break it would be to type a space in here, and then click outside it. That remade the object because just typing a space dirtied the text string. So it says, oh, I got to make a new one. And it makes the new one, and then it reformats it. So it looks just like the old one, but it's new now. Okay. Now, yeah, taking this out. Whoops. Taking this out and reconnecting it doesn't do a thing. Have to actually make the thing create output. This seems like a horrible bug, and it will seem like a bug for maybe the first year or so until you realize that it's actually a feature. Let me show you how you can even confuse yourself worse. Now what I've done is I've set up an argument between two sources of control. Right? Here's my low A, here's my high A. Which is it? Well, you can't tell from looking at the patch. So maybe you shouldn't do this. You're perfectly welcome to. And there are situations where you would want to, but it's not likely that you would want to display the value coming in two ways, one of which is guaranteed to be wrong at any given time. Right? So you might indeed want to have two different possible sources of frequency that are active at different times. And in fact, that's an important aspect of the way TV is designed the way it is, that you can do things from different sources. But if you do that, then you might not want to see what each source is trying to tell the oscillator. You might want to see what the oscillator itself is actually doing in the patch. So I could do that by either clarifying or further confusing, depending on your point of view. Let's do this. Now notice the oscillator is still going along at 447 hertz, right? It doesn't care about any of this stuff that I've been reconnecting because these are messages. The messages are not flowing until I do something. I'm just making a patch. Okay? But now if I do something like say, oh, 440 please, then I've got 440, but now at least I can see what it is. Okay, so this is maybe a little bit better. And this will be okay until I confuse myself again by bouncing directly into here. Okay, this is not computer science, this is music. Alright, so let's get rid of that because this is just confusing. I just did that to warn you how you can confuse yourselves. Okay, so this is frequency, and while I'm at it, oh yes, right, and of course I've already shown you, I think, that this makes these kinds of changes, right? Right, okay, and the amplitude is a similar situation, except that I wouldn't dare do something like put 440 in here, would I? No, that's not good. Now, remember, I have the mixer turned way, way down right now. If I had done that at home with my stereo at its usual setting, I would have jumped out of my chair. Okay, what that did, well, I can't even graph it for you. Oh, I can clip it and graph it. Yeah, let's do that. Okay. So I'm going to say clip -1 to 1, so that in fact I'm simulating what my computer is really putting out. And now, as long as I'm between -1 and 1, everything is good. But when I say, "Oh, I want 440 volts, please," then I have to say, "No, then I see that. Okay. Oh, yeah, that didn't graph terribly well. It's trying to do polygons again, I think. I'm not sure. All right, so that's, and this is what, Jimi Hendrix got when he played a note on his guitar. Basically, the tube was always either saturated or open, and then you got what is essentially a square wave. This is a computer music technique. It's been elevated to it's been elevated by having a name. It's called wave shaping, and you will hear more about this or read more about this in chapter 5 of the book, but we will hold off on all the gory details until later. So different ranges of numbers might be appropriate for selecting frequencies as opposed to selecting amplitudes. All right. Also, okay, now we're multiplying by 0. No matter what you multiply by 0, you get 0, and it looks like this, and it sounds like what you're listening to. Okay. Now, I meant to say something and didn't finish saying it. You can. You've seen me do this to number boxes, and of course, if you're in edit mode, you're doing that and getting frustrated. So you get out of edit mode and you're doing that. But you can also type a number in, and then if you hit character turn or enter, the number is generated as output. So if I do this, the output isn't 4, it's 4, it's going to be 4. It'll be 4, in fact, if I hit enter, but if I want 440, I'll do this. And then enter, ooh, okay. And then the number came out. All right. Now, I did that so that I could do this. I'm going to go here and I'm going to type the number 0.1, enter. And now we've got a complete computer music instrument with amplitude and frequency control. All right. Now, this is kind of stupid because if I reach for this number box, zeroed out. Of course, if I just click on this and start scrolling or dragging up and down, it's impossible for me to make a nice sound because I can't get anything between 0 and 1, which is completely quiet and full blast. It is true that you can hold the shift key down and ask this thing to go up and down in hundredths. But in fact, if I were designing this as a patch, I would do something a little bit more user-friendly. I would take the thing and divide it by 100 or something reasonable like that before I started messing with it. And that's going to take me outside of my budget of 5 object types, although it's nothing but times without the total. Actually, now okay. What I'm going to do though is now go back and show you a little bit more about manifestations of differences between signals and messages. Yeah?
I'm sorry, how do you actually type a number value into the number object?
Oh, I didn't tell you something important. You have to click on the thing, which doesn't give you any visual feedback, which is stupid, it should. And then you can start typing. And then you hit enter to make it go in.
Where am I out of edit mode? Do that.
Oh, and if you're in edit mode, it won't do it for you.
If you're in edit mode, it won't?
Yeah, it has to be in run mode, or locked if you like.
Okay. Okay.
Got it?
Okay.
Good. Yep, that's key. Okay, so the final object that I want to tell you about is print. Oh, no, not comments. Comments I'm just using but not explaining, but comments are very good. It's the object which is called print. So let me do a very quick review of something important. What I've been doing on the put menu so far is mostly reaching for objects. There are three things that I've shown you to do that don't require just making an object and typing into it, because these are user interface objects. They're things that make the surface of your patch do things. And they are the number box, which is here, the bang, which is here, and the array, which is here. Everything else that you see here is just plain old objects. All right. Now what I want to do is I'm going to save this. Yeah, right. So now we have this print object without a tilde. Okay, so it expects not a signal but a message or messages. And now if I change this value, you get to actually see what the thing is doing. Cool. Okay, this is how you debug patches. You know, your patch. You want to know what your patch is doing, and the way you find out is if there are messages going through. You can sometimes help yourself with number boxes, but frequently, if you really want a complete record of what's going on, you just hook a print up to something. And then if you want to know what's going on with a signal, you have things like this tab right tilde or print tilde, which prints the things out here. And those two things have signal inputs, so they're appropriate for talking to signal outputs. And they will show you how something is varying in time as a signal. There's something else I need to tell you about that. Let's let it sit at that for now. All right, so back to frequencies and amplitudes. Questions about this?
So, and what was the keyboard shortcut for connecting two objects?
Oh, there's no keyboard connect. Oh, okay. There's one trick to that. There's only one way to make a connection that doesn't require that you actually do the drag thing, which, by the way, is horrible on a trackpad. And that is, you have an object and you want to make a new object and connect it to it. Oh, so it's not the case now. So while it's selected, you hit Control 1. Control 1 in general just makes a new object. But Control 1, if one other object is selected, Control 1 means make a new object and connect to it. Other questions? It's all good. Yeah?
Does print run automatically when you turn on the
Yes, right. So print tilde, you have to click it. In other words, print tilde, you have to send it a message to tell it to operate like this. Let's see, I'm going to do this. No, sorry, we're getting messy now. Turn it on. Oh, look. Oh, right. I've got the amplitude down to 0. Oh, cool. Now I've shown you how you can make a patch that shuts up but is still running so that you can debug it without listening to it. Just make your patch have an amplitude of 0, make it be a control. The patch is kind of muted in the sense that everything that I'm doing is eventually getting multiplied by 0, so we don't hear it. But we can still go through and do things like look at the oscillator numerically, or look at the oscillator graphically. No, we can't do that, but we can do this. Right? And we can do that without having to have everything come over our speakers, which is a good thing.
Is there a way to graph in real time?
Is there a way to
Graph in real time?
Yeah. There's an object called metro, which is a metronome, which will send out a message repeatedly instead of just once when you click it, and then you can have it just graph 10 times a second or whatever you want. I'll get to that. It's out of my object budget right now. Yeah?
Can you put a bang on an oscillator and have it play over and click it?
No. Oh, yeah. So how would you make something play when you click it? Yeah, I have to introduce more objects to do that too.
Okay, that's fine.
So in fact, to make something start playing, you don't tell the oscillator to start playing because it's always playing. You have to multiply it by something and make the thing that it multiplies by quit being 0. And that in fact is the kind of the crucial thing that I'm I'm hoping to find about 5 different ways of saying today, is, yeah, you turn things on and off, not by turning them on and off in the sense of computing and not computing, but by multiplying them by numbers that vary from 0 to not 0. And the reason for that is, obviously you would save computation time if you just turn the thing on and off, but that doesn't make for nice musical beginnings and endings of notes. You want things to turn on and off smoothly, which you'll have to learn how to do. But the only way to accomplish that is by multiplying the outputs as a way of controlling the amplitude instead of simply by turning things on and off. Okay. So, and a wonderful example of that is this. Let's multiply ourselves by not a number, but by another oscillator. And let's maybe go at 1 hertz. Okay, now, oh, we're too loud for the mixer again, right? So we're hearing distortion. So rather than just take that line down, I know how to deal with it now, and I'm going to. So let's say, not only we're going to do that, but we're also going to have a multiplier for controlling the overall amplitude. Like that. And now we have a patch that does something interesting, but it doesn't do it at full blast. Now I can, I'll start paying attention again and being careful about the output so that I can turn the mixer up. Oops. Oh, right. Okay, so now what I'm doing is I'm taking this nice oscillator. It has a pitch of 330 and making it change its amplitude so that as I click and look at the signal at different moments in time, I get different strengths. That's because this one is just making that waveform, whereas this other one, this 1 hertz job, if I look at it, okay. Now remember there are 1,000 points in this array. That means the array has a 44th of a second. So at the speeds that we're looking at, you don't see very much variation at all in a 1 hertz sinusoid. But of course you hear variation because there are 44 of these things going by per second, faster than the video frame rate even, right? And so this thing, even though it looks like it's doing almost nothing, is in fact varying. It's going once a second, so what it's really doing is going up, down, up, down, up, down. And what you hear is 2 peaks per second, because you hear a peak when the amplitude goes up to 1, and you hear a peak when the amplitude goes down to -1, which means it got multiplied by -1, which is also full blast. Yeah?
Is this different than Tuesday? Because Tuesday we were doing something with the frequency?
Yes. This is a completely different situation from Tuesday's situation where, this anticipated the next thing I want to do in fact, where there was an extra oscillator all right, but it was controlling the frequency of the oscillator we were listening to. So that patch, let's see now, I'm going to do this. I'm trying to decide whether to, okay, maybe it's time to save as. So the first thing is, now we're saying 5, a more amp frequency, unfortunately. Oops. So now what I want to do is say, okay, this is good, but there's also the possibility where I had my nice oscillator. Get rid of this. Here's an oscillator. And then I had an adder. And I was adding 440, I think. Hey. What did it do? And then I had another oscillator with another amplitude control, so I think it was something like this.
Isn't that what multiplying by 440?
Let's see. Oh, thank you. I don't want to do that, do I? Yep. Okay. Now we have an oscillator. It's going to operate at some frequency, but unlike last time, to give you more fun, I'll hook up a number there. I didn't have numbers last time, so I had to be a little bit more severe with you. Okay, now let's see what this does. Oh yes, now let's do this. All right, now we're getting complicated. So,
What?
this is yesterday's patch with a little bit more controllability, but doing exactly the same thing. So what's happening now is this is the oscillator that's making noise, and morally speaking, it's speaking at 440 hertz. But in fact, we're taking that 440 and we're adding another audio signal to it. And that audio signal is the output of an oscillator whose frequency and amplitude we are controlling. Now what was happening last time was this oscillator said OSC tilde space 6, so that I initialized it to 6 hertz. And this was times tilde, I forget, 30. And then it was doing a fixed thing. But now I'm using number boxes here to fill in the frequency and the amplitude of this so-called modulating oscillator. All right. And now if we turn this thing on, like this. Oh, let's turn this one off. Now I have to turn the patch on. All right, there's 440 for us again. And now if I say this oscillator will run at 3 hertz and be 30, and then we got this, right? All right, there's that. And now this one was doing something different, which was this. Let's go up to 440 so we can compare. This is a changing amplitude. Yeah?
What's the point of adding the 440? Why don't you just put the oscillator tilde space 440? Or is that the same?
No, to add it. If I did that, then it would be overridden by the values coming in. It wouldn't be 440 plus the values.
Oh, okay.
Yes, so, right. That's a good question. So going back to this one. Ugh. That's really ugly. I don't know. It's not beautiful yet, but it's a thing. Right. So now, yeah, I could have tried this. Don't want that. I just want to run this right in and then say 440. But now this 440 is actually being overridden by this. And in fact, what I have really is an oscillator that's varying between plus and minus 6 hertz. So nothing is happening at all that we can hear anything. Oh, yeah, it's very easy to make sounds that you can't hear. And the reason you can't hear this sound, we can look at it and see why we can't hear it. Let's do this for clarity. It's just not moving fast enough for us to hear it. Yeah?
For the lines that you have connected, can you just like grab it, disconnect it, and move it to a different one? Or you have to take the line off? And
Yes, you ought to be able to disconnect it either at the output or at the input,
Right.
but it doesn't do it. You have to delete the old line and make a new one. Yeah.
Yeah, this is probably a silly question, but there's not like another window that would show you the signal flow, like signal routing, right? And there's no way you could just kind of know how to troubleshoot.
No. Basically, no, there's no other window here except what you, I mean, you can build things that do that, but there's nothing built in. Yeah. Okay, so that didn't work, but this works. In fact, oops. Oh yeah. So now at this point, I'm just confusing you by leaving this 440 and it's not germane. I'm going to save that. And furthermore, I'm going to even improve it by doing this. Now everything is up for control. Don't try this at home. And then you have this, which is how fast it's going, and you have this, which is how deep it's going. Now you have frequency modulation.
that sounds right.
All right, this is 1960s computer music. frequency modulation. Frequency modulation is taking the frequency of an oscillator and changing it. Modulation is a musical term that just means change. Right? In fact, you shouldn't even call it modulate. Well, maybe it means changing with time or something like that, or repeated change. No, because when you modulate harmony, it's not repeated at all. It's just change. I don't know, reason to change, maybe. So what we're doing now is we're taking this oscillator. Its frequency is the sum of a base frequency, or a center frequency if you like, and an oscillator. This is an oscillator whose amplitude and frequency are 172 volts and 82 hertz. Right? This is different from, okay, now this is taking this oscillator and changing its frequency by talking to its input. This is taking this oscillator and changing its amplitude by multiplying its output by something. And that, in contrast to the other things, makes it sound like this. You can make sounds with it. This is trigonometry. If this is cosine A, this is cosine B, this is cosine A, cosine B, which we all know is half cosine A plus B plus cosine A minus B. So here,
Right.
right? So algebra 2 is just this. Or to put that, actually to put that backwards, people will tell you that the reason if you have two oscillator or two sinusoids that are nearby in frequency, they beat when you superpose them. It's because they are gradually going in and out of phase. That's the layman's explanation of what's going on. The truth is that the sum of two sinusoids is algebraically equal to the product of two other sinusoids. It's the same relationship I just told you. And the product tells you that it's changing an amplitude, which is the beating you hear, and the sum is the two that you put together. And I'm doing that backwards. I'm taking an oscillator here and making it beat by multiplying it by another oscillator that changes its amplitude, and that's algebraically equal to those two that you had to add the beat. It's the same stuff. You can do it either way. This, however, you can do to a real signal. And try that at home and see what you get. Find a politician you don't like and multiply him or her by 30 hertz oscillator, and then you will get a pleasant surprise. Right, so this is oscillator changing the amplitude, which is sometimes called amplitude modulation, sometimes called ring modulation. That's a historical term, which you'll never get out of. This is frequency modulation, which is taking the same oscillator. Oh, you know what? I should make a nice comment to emphasize which important oscillator it is. The main oscillator, if you like. This is taking this oscillator and changing its input. You can do both even at the same time if you want. Yeah?
Wait, so the number that's 0 right now, on the
Yes.
right-hand side,
This one here.
is that the amplitude of the overall?
Right, yes.
Okay.
So in fact, this and this, those are volume controls or gain controls that I have on the outputs of both of these patches so that I can turn them on and off, which is not making them compute or not compute, but just multiplying them by a tenth or 0, depending on whether I want to hear them or not. And of course, we don't hear them because I can also turn the DSP off, so this is a more correct way of showing you what's happening right now. Yeah?
Yeah.
Other questions about this? Yeah.
So what is cross modulation? Is that not an official thing?
I would use that to mean that I was taking one sound and multiplying it by another sound, or maybe even doing something else to it depending on another sound.
Okay.
But I don't know if that's a strict definition.
Okay.
There's also, well, there are lots of terms. We'll get further along and see all sorts of other things. Other questions about this? Okay, so, sorry to belabor this, but I'm going to belabor it slightly. All right, so what we had, just by way of review, is we have two ways of looking at signals, which are print tilde and tab right tilde going into an array. This one is more work, but it gives you a nice graph. It's more work because you have to make a button and choose when you're going to do it, and make a graph that agrees in name with the tab right tilde. I could have 5 or 10 arrays in my patch and 5 or 10 tab right tildes, and they could talk to individual arrays if I wanted to. All right. This, I took it out. There's a print without a tilde, just print. And that is a thing which takes a message input. And by the way, well, of course, as I showed, it's good for printing these things out. But it's not good for printing these things out. And furthermore, it'll even refuse to allow me to print a nasty message if I do that. You can't take, in general, you cannot take a signal and put it into a message input. A message input that wouldn't know how to deal with 100 numbers a second or messages a second. I can take a message output and hook it into a signal input. As long as there's not a signal going into the signal input as well, the message will simply set the value of the signal. So numbers which are messages are promoted to signals automatically by the program, but not vice versa. Right. And what else do I have to tell you by way of review? Oh, one other thing. This is a review, but this is a way that a thing that I could have confused you by. If you do this, this input doesn't take signals. It tells it that it's messages. That's to say, multiple or signal binary operations like time and plus. If you feed it an argument that initializes the value, that also tells it that the inlet is expecting messages as opposed to the signal. If you multiply two signals, don't give it an argument, just say times tilde. And all this should be explained in the help windows for all these things. So just by way of a reminder, you can always get help on any of these puppies. Here's help with the oscillator, and I even have a little thing to graph what the oscillator does.